The PBL that I used for this assignment was building a better cereal box. The well-defined outcome is that students will create a cereal box other than a rectangular prism using a 20-inch by 30-inch sheet of cardboard or poster board. The cereal box must be self-sealing, openable, and resealable. Students will present the product including schematics and specifications and survey findings to a panel of General Mills engineers. The objectives for this PBL include math objectives, as you can see here, including measuring, finding surface area and volume, finding area, analyzing the relationship between 3D figures and 2D representations, looking at nets, understanding nets, and distinguishing the purposes and differences among types of research, including surveys, experiments, and observational studies. The English objectives are that students will work productively in teams, they will contribute relevant information, develop a plan, they will write expository and procedural or work-related texts, they will write persuasive texts, and an argumentative essay. For visual media analysis and production, students will produce visual representations that communicate with others and use a range of techniques to create a media text and reflect critically on the work produced. And for physics, students will use a systematic approach to answer scientific, laboratory, and field investigative questions. They will also communicate valid conclusions supported by the data through various methods, such as lab reports, labeled drawings, graphic organizers, journals, summaries, oral reports, and technology-based reports. There are also art objectives. The art objectives include communicating ideas through original artwork, expressing thoughts and ideas creatively while challenging the imagination, and using visual solutions to create original artwork by problem solving through direct observation, original sources, experience, narrations, and imagination. The materials necessary for this PBL are, as seen here, poster board. Each group will need about 8 sheets of poster board as they will create multiple different prototypes. They need markers, they need scissors, ruler, glue, grid paper, and they need a computer to be able to research and also create their artwork for their design. For the engage piece of this PBL, students will watch a couple different videos regarding redesign of a product that already exists. The first is a bladeless fan created by Sir James Dyson, and the second is a redesigned shipping box created by 2 students at the Cooper Union School. They will compare the old and new designs, and then we'll take a closer look at the redesigned shipping box and demonstrate their understanding of nets and how there are many different net possibilities for one solid. I really liked this engage piece because it showed students how things can continually be improved and also how new ideas come to be. The redesigned shipping box created by the students was part of a project for their school, but it's something that they created to hopefully actually be patented and used in mainstream manufacturing. This is a picture of the nets that we drew that all represent a cube. As you can see, as we were working on these, we had a little trial and error in some cases. These are not all unique in that some of these, if you rotate them or reflect them, they create something that's already here, but it's what we came up with. After students discuss and figure out the nets of a cube and how there's multiple different nets of a cube, then students will determine surface area and volume formulas for the different solids. So students will be able to explore this on their own and hopefully come up with a formula on their own. Students will be encouraged to use the nets to come up with these formulas. I think that the formula for surface area is easy to figure out from the nets. And the volume may not be as obvious, and there may need to be some teacher lecture or just explanation of how to find the volume from the nets and thinking about what volume means. It's possible that students will need to be provided with manipulatives and or some sort of demonstration to show how the volume is different in different solids and or how it's different in different sizes of the solids. At the end of this portion of the PBL, students should have a formula chart similar to this, where it shows them they've written down the volume and surface area formulas for the different solids. In the next stage, students will start researching, brainstorming, and analyzing. Each day, they will continue to look at their prototype and make it better. And in this stage specifically, they will discuss the specific characteristics of a cereal box that are valued by the consumer. And so they need to speak with different people and figure out what these characteristics might be. So here's an example of the survey that they may use later on in the project after they've spoken to people to find out what characteristics are important. So for example, visual appeal, storage, functionality, and volume. Those are things that would be important to the consumer. And again, this survey will be used later on in the PBL after the prototype has been designed and produced. Here is a video of our brainstorming session. So as you can see, we originally were thinking cylinder, and so we're trying to figure out how we might seal the cylinder by looking at an oatmeal box. And then eventually we came to a triangular prism, and we figured out that that might be a little easier, and the sealing of the prism would be better. I mentioned that we should use trapezoidal tabs at the bottom in order to seal it the best way. So here's more of our planning process. As you can see, I have a bunch of the nets drawn. I've got the 3D solid drawn of what it would look like when it's put together. Up here, I've got my measurements. I use Pythagorean theorem to try to figure out what the height of this triangle base would be. And so this is a bunch of our thoughts and eventually our final net that we use to construct our prototype. So here are some of our here's our prototype box. So this is the net, as you can see, the trapezoidal tabs. And we did figure out that we would actually not need one of these tabs because you can see we have 4 faces when we actually only need 3, but the 4th is the one that overlaps in order to seal the box in some way. And so this trapezoidal tab was actually not necessary. And these trapezoids up here are the ones that are going to insert into the face in order to have the resealable component. So here's here's a view of the box actually put together. As you can see here, here's the slit, and that's where the tab goes into. And lastly, another view sort of from the front. Because it's a triangular prism, we decided to have 2 tabs that reseal on both sides so that it was better sealed. After students have built their prototype, then they will come up with a design for their box. They will need to use a computer for this, and so here's an example of what students might come up with, including nutritional facts, and then the main side of the box being the name of the cereal, and then these other 2 can be used for other things. I think designing this while looking at the net would probably be the easiest way to do that. After students have done their design, then they will explore public opinion by surveying their peers regarding box preference and other elements of their rubric. So the students will use the survey they created in an earlier part of the project. And so this is an example of the survey results. They had to survey 100 millennials, as that's their target audience or their target market. And so then from this feedback, they will then go back to the drawing board and adjust their prototype accordingly. So, for example, based on the survey, we went to improve visual appeal and functionality because we can see that those were pretty low. Poor and good were the majority of the responses there. And we might want to consider improving the bottom seal of the container, as I mentioned earlier, taking out that one tab, and possibly changing the size of the trapezoids to make sure that it seals the best. After students have gone back and adjusted their prototype, they will then make a presentation. Students will present their projects to an expert panel. In the well-defined outcome, it mentioned that students will present to a General Mills panel. That may not be an option for you where you are, but you should try to find some sort of expert in the field for them to present to make it more related to real world. Ideally, you want professionals from the marketing or merchandising industries to hear the student presentations. Students will, in the presentation, they will include product specifications, the net of the product, including any tabs for assembly and specific instructions for assembly if necessary, and the survey results. Students will then conclude with a convincing pitch of their project. Lastly, the extension for this PBL includes 3 different activities in reference to platonic solids. A platonic solid has faces that are congruent regular polygons with the same number of faces meeting at each vertex. In preparation for these activities, students would actually need to define some terms, and then they would be able to do these activities. Students are encouraged to pursue these should they finish their final presentation edits early. Lastly, the students will have an evaluation, which may include some multiple choice questions regarding nets and surface area and volume. Here are my references. The websites are simply for the pictures that I used, and of course this is our companion book where the PBL came from. I really enjoyed conducting this PBL with my family, and I think it was a good learning experience for me to see how a PBL might work and what things need to be considered as you work through a PBL with students, considering that students are on different levels and especially maybe not having done the PBL yourself before, anticipating where students might struggle and need help along the way. Thanks for listening.